All right, here we go. Question number 17, the last question from our 1316 homework number 2 in MyLab Math. They want us to find the amplitude, if it exists, the period, the phase shift, and the graph. So the first thing that I want to let you know is that only sine and cosine have an amplitude. This is cosecant, no amplitude, okay? Only sine and cosine have an amplitude. Next, they want us to find the period. So for a sine, cosine, secant, or cosecant, for any of those four, the period formula is 2 pi over b. B is the coefficient of x. So this is going to be 2 pi over 6, which will reduce to pi over 3. And so that's going to be our period for this function, pi over 3, and our phase shift. So the formula for the phase shift is negative c over b. C in this problem is negative pi over 4. So when I plug that in for C, notice there is already a negative, and two negatives are going to make a positive. So that'll be positive pi over 4 over 6, which will simplify to pi over 24. Holy cow, that's a small phase shift. I hope it's right. Let's see. As a fraction, pi over 24. Now then, let's talk about graphing. We're going to follow the 6-step method of graphing a sine or a cosine wave, because to graph a secant or a cosecant, you basically use the same technique as you would sine or cosine, except for the very end, okay? So we have cosecant, so we're going to pretend like that this is a sine function, okay? We're pretending like it's sine. The reason is because sine and cosecant are related. They're reciprocal functions, so we're going to follow the rules for sine. And like I said, at the very end, we will do something different than if it were sine, okay? All right, so the first step. Let's see, the first step is starting point. And if you have a sine function, sine starts at the origin. So our first point would go at the origin. Sine starts at the origin. If it was a cosine, we would start at 2. But we have sine, so we're going to start at the origin. That's step number 1, starting point. Step number 2, phase shift. Okay, so our phase shift is positive pi over 24. And so that means we're going to shift this point to the right because it's positive, and we're going to shift it a distance of pi over 24. So I'm going to call that pi over 24, and there's my new starting point, okay, after we deal with the phase shift. Step number 2, phase shift. Step number 3, wavelength, which is the period. And our period is pi over 3. That's the distance it's going to take to make one complete cycle. And then my question for you becomes, how many pi over 24s does it take to make pi over 3? Okay, let's think about this. How many pi over 24s does it take to make pi over 3? And the reason I'm asking it that way is because I'm going to have to count by pi over 24s, because that's my spacing, to equal the period. And then that'll tell me how many hash marks to go, okay? So if we think about this a second, we're going to ask ourselves, really, how many times does 3 go into 24? And I think that is 8. So 8 over 24, 3 times 8 is 24. That'll reduce to pi over 3, and that tells me I need to go 8 of these spaces. Hot dog. We're going to have to scoot this over, and we're going to have to extend, I think, this line here. So here we go. Pi over 24. Starting here, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Now from the origin, that is 9 pi over 24. Do you see, if I count from the origin, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and each one of these is a pi over 24. So that is 9 pi over 24 to get to the end of the first wavelength. That's going to be the end of the first cycle. Now, step number 3, wavelength. We can now see that this distance here, if I start at 1 pi over 24 and go to 9, that is a distance of 8 pi over 24, which reduces to pi over 3. And remember, that has to be the period. Pi over 3, that's a wavelength, okay? Now, for step number 4, I need 4 spaces. Well, from start to finish, I've got 8 spaces. Did you see that? I've got 8, and I only need 4. So I'm going to come back here, and I'm going to count every 2, okay? So there's 1, 2, 3, 4. Okay, so now that gives me 1, 2, 3, 4 spaces. And the reason I need 4 equal spaces is because the hash marks are where my points go. So now that I've got my 4 spaces, that's step number 4. Step number 5 says lay out your points. So at this first blue hash mark, if I scroll up, I can see that the original 2 was positive. So at the first hash mark, I'm going to be up at positive 2. If this 2 up here would have been negative, then at the first hash mark, I would be at negative 2. So that tells you where to go first if you're starting on the x-axis. Whatever goes up must come down. So at the next hash mark, I'm going to come down to the x-axis. And then at the next hash mark, we're going to be at negative 2. And then finally, we're going to return to the axis. And step number 6, connect the dots. Okay? And so we get our nice, smooth sine wave. Whoops, I actually did a sine wave. That's what it would look like if it was sine. Remember, our original function was cosecant. So instead of making a sine wave, let's erase that. What we need to do at step number 6, since it's cosecant, is we need to turn every x-intercept into a vertical asymptote. And the other points become our humps and bumps. At least that's what I call it. So this is going to curve up like so. And that one actually got into the asymptote. It should not get into the asymptote. Bam, it should approach the asymptote, not cross it. And then this down here is going to approach the asymptotes and not cross it. And then that would be one complete wavelength. That is one period. An up hump and a down hump, that is one period. Now that is the cosecant graph. And we're going to come over here and see if we can find an answer choice that fits this, okay? So we need the first asymptote to be at pi over 24. And we need the first hump to be above the x-axis. So that takes out A. A can't be right. C can't be right because the first asymptote is to the left of the y-axis. D can't be right. See, the asymptote is to the left of the y-axis. So C and D don't even have the asymptotes in the right place. And then A and B do have the asymptotes in the right place, but B is the answer that has the humps in the right place. So that's going to have to be B. And that's it. That's it for this second homework assignment. Man, I hope that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.